Okay, hi. This is the circuit W, just an example that is going to be solved using the method 1 and the Proteus virtual laboratory simulator to get straightly the true table. That is the purpose of this method. Let's think about simply on using it to get the true table, just like that, running the simulation. So hi, let's just start the recording of the method 1 for analyzing the circuit W, for example. Okay, 4 inputs, a single output, and this is the entity circuit W, this box, and down there you have the schema, right? You see some gates and some buffers and some inverters. So what you want here is this time to try to find, as usual, the truth table. Okay, the output W for every single input from data 1, data 0, A and B, that goes from 0, 0, 0, 0 and down to 1, 1, 1, 1. And this time the method 1 implies using a simulator, and this means that we will go straight to the lab. All right, we go straight to the lab and we pick up chips. All right, for example, this one, the 74 LS-20, that is what we are going to do. We will go and fetch gates from the proper library. So they are going to be 74 LS to make it easy, right? So those libraries has a simulation model so that you can apply logic values at the inputs and you can register and you can measure the output. So here, for example, one thing that you can do is to connect a LED that, for example, this way, by means of a limiting resistor, so the LED will light when 1 and will have no light when 0, right? So something that simple is going to be for you to monitor the output value. Another way is using a voltmeter, a voltmeter, a DC direct current voltmeter connected to ground, and here, the positive connected to the W is going to be for you an instrument for measuring 5 volts, which is equivalent to 1, or 0 volts, which is equivalent to a 0 logic, right? Something that simple. And then, apart from picking the logic families and connecting some device at the output for monitoring the logic value, you perhaps, what you have to do is to drive in some way or another the inputs. And here is where you can have a resistor and a push button. For example, this may be the push button A. So you can take this node as the output. So you see, if this is BCC, this is, the button A. So in some way you have now, for example, a 1 when no clicking, or instead you get a 0 when clicking. Okay, when you click the button, you are making a straight connection to the ground, so you have a 0. And when you are not clicking, like now, what you get is, for example, a 5 volts, because this is what you are requiring here. In the lab you need a battery. So in this case, naturally you will use a battery, something like this, for example 5 volts connected to ground and connected to the BCC, which is the value that goes to every single gate. Perhaps this connection is a hidden pin, but doesn't matter, it's here. Every single gate is connected to a voltage and the ground, so you can develop ones and zeros, all right, depending on the function of the logic gate and the inputs that you are settling as a stimulus at the ABCD or ABD1 D0 inputs. And perhaps so what goes next is go into action, because if you've been planning all this in your mind on a sheet of paper, this method requires nothing but to go to the lab, as I said before. So you have simply the circuit, okay, and your mission is to capture the circuit, you know, get from the library the components, attach them to wires, so you will be able to have connections to every single gate that you are picking, and then, you know, well, this is going to be a drawing, you know, a schematic, so you have to have this file, and then it has to have the proper extension, and it has to be in the proper folder. So we can do that now, you know. Find a similar circuit to copy and adapt. That's the best way to go through these. You need probably in digsys.upc.edu you will find similar examples, similar circuits like these that you can copy and save as. So that's the point. Find a similar and adapt and copy it to the right folder, right? So let's establish the right project folder. And that project folder may be, for example, your hard disk or your network drive, if you are using Samba or something like that. So you have a network drive or your local CD, you see something like this, slash CSD is the name of the subject, and now P1 is, you know, the projects that you are solving now are in this P1. And so now what you need is, for example, the name Proteus, because here is where you are working now using the method 1, Proteus or circuit W, whatever. So Proteus is okay, and now the name of the circuit. So we don't circuit W dot project design suite PRJ project, right? So that's the file extension for this kind of projects in Proteus. So, you know, let's plan this as well all the time. Get a name and a proper folder for your project. So the next one, for example, solving the circuit by the method 2 is going to be similar, but it's going to have another folder. All right? So you can have the same names for the files, but because they are located in different folders, this is not a problem for you anymore. So from the very beginning, let's plan the way to proceed, you see, to go down to the final truth table, you see, step by step. So let's go this way. Find a similar circuit to copy and adapt. Place it in the right folder. And now what is next? Naturally, if you already have the, you see, it's run Proteus simulator, which is like developing, you know, developing the project towards the solution. So now you are running the Proteus and you are going to capture the schematic. This is what you are going to do with the right library, you know. Pick parts, you know, the library symbols, pick parts from 74 LS UC library. All right. And once the circuit is finished, you will have this entity, and when you go into the circuit, you will have this structure. When you have the entity and the internal architecture completely finished, you see, what goes next is to simulate, but not just for running it, but you know, you will simulate the circuit for all the combinations. This is what you are going to do, right? So you see, kind of run, you see, establish a given plan, run the Proteus, and finally simulate all the combinations So you can get the result from 0, 0, 0, 0, 0, 0, 1 and so on to the end, right? So here it is what you're going to get, the solution of the problem, the complete truth table. So let's do that practically. So let's accompany this recording of this whiteboard with a real thing by means of capturing my computer's screen, running Proteus and the like. So you will see the way to go through this, because it is very easy, but you have to do it by yourself till you get the results, okay? So let's see the way to organize this Proteus simulation. So you have to go to digsys, right? And then jump to P1, because this is the project where this is located. And you know, this is the starting of everything, so you better go to learning materials, and here in the learning materials section probably you have a Proteus tutorial, right, in order to solve this analysis of the circuit W. So you click the Proteus tutorial, and here you are some example circuits from which you can make modifications. This time the circuit W is already available here, right, completely solved. But if you have to start, the best way to do that is to take an example. For example, you can click the one in the figure 1, right? This one, okay? So you can click here and you can open the circuit in Proteus, right? And that is the circuit, you know, you see a box, ABC, an output, and then if you go to the child sheet, you click in Ctrl+C, you have a very similar architecture to the one of required in circuit W. So this is your time, right? This is a good example to copy as it is and save as. So let's do this job of file, save the project as, you know, let's find that in the LCSD this semester, P1, you know, Proteus, and you know, let's name it, instead of combinational circuit 1, this is going to be circuit W, right? Proteus design suite project. So that's the save that you have to handle here. So now you have the file in the right folder, right? That's it. So now is when you can start making modifications to the circuit so it becomes the circuit W. But before that, because you have taken that from the internet, from Digsys web, you better click play to see if this circuit is working. And it is working. You see, you can input different logic values, and then the circuit is responding with ones and zeros depending on the combination. So this is exactly what you have to do in the end for the circuit W. Okay, so perhaps now you can stop the simulation and start making changes, starting by the name itself. Okay, so in order to change the name, instead of COM circuit to be circuit W, you better go to the child sheet, select it all. So you put that into the clipboard, copy to clipboard, you go to the top architecture again, and now it's time for changing this to circuit W, like this. So now this is the circuit that you are going to analyze. So you go to the child sheet again, and now there is a new sheet of paper because you have renamed it. So with a right click, now you can say paste from clipboard. So now this is your circuit, okay? And then, for example, this is okay to be the chip 1, so let it be like that, okay? You can delete the text if you are not interested, or any arrows or whatever. So very good. So now you know that about Ctrl+C, so you can get rid about these things. Okay. So the circuit W is the name of the internal architecture that is connected to this symbol or entity. All right, chip 1. So now it's time for starting modifying the chip. For example, instead of C, you can rename that to be D1, right? Now you can copy. With this block copy, you can copy, so you have 2 of them, and this is going to be D0, Then the other one may be named A, and the other one may be named B capital. That's it. That is what you need. And the output the same. You can rename it to BW. So now this is going to look like your circuit. All right. Perhaps you need another value here, another logic value, so you can do the same stuff. You can copy that thing. Okay. You can copy it as a block, and now you've got it like that. With a wire, you make that connection. So you can name this to be, or there's no need, okay, as you like. You can give them a name or not. It's not necessary, but now that you have the possibility, edit label D1, and this label the same, edit label. Edit label, right? Sometimes with this click. D0. So that's the circuit, that's the top entity. This is the way you have to go starting. And now it's time to go into the child sheet like that. So now you need another input. So what you can do here, if this is A and B, you can start modifying the circuit. Delete the wires that you've got here. So you can delete that one because it's not required anymore. That one, the same, the buffer. This one is okay. So you've got these 2 gates, which perhaps you will like to use in your circuit. Not the OR. So you can delete that one as well. So you have the symbol, which is going to be the output. So let's name it W, right? And then this gate is going to be the output. So you can make the connection now. Okay. And now is your turn to move, for example, this one to the left side, and you can copy it again as a block this way. So now you've got the 4 literals. So now is your turn to name them. Instead of C, let it be the one input. This one is not necessary, so this is going to be D0. That is A capital and B capital. That's not important now, but it's better to be like that. Okay, so A, B. So now if you like, you can modify the text down there because this is simply a text. Okay, so this is D1, D1 not, D0, D0 not. And now you can copy this many times like that. So this is A not, B, and B not. Okay, so here you are, the literals. If you need more room, you only have to do such a thing to get more wiring connections. So let's start with the first gate, which happens to be a NAND, or not a NAND, but a NOR of 2 inputs. And so now you know that you have to use 74LS, not 08, but another one, which is going to be a NOR. So let's go and pick parts, okay? Pick parts, 74LS. And now you can go and browse, or you can go and browse for the NOR. That's one way to go, right? Here you are available, all the logic family, okay? Or instead, you can have that one. So this is the one that you need, you see, 74 LS. So you double click, and that is what you've got now in your drawer. You see here you are the many components. You can filter that if you like, tools or view or design. It is the tidy design tool, right? If you click tidy design, okay, here you are on the right side, you see the devices that are now located in your schema only. So now that you've got the gate, it is your turn to make connections, okay? So for example, this is connected to a NOT, and the other input is connected to B. Very well, so you've got one gate. Now the next one is a NAND of the same family. You see 74 LS, so you can proceed. If you like to get rid of this label text, you can go to the properties and add here in the other properties a white space, you see, like that, and in this way you get rid of this text thing. Very well, so now you can go to the properties and reach the 74LS00, that you know that is the NAND of 2 inputs. So you can click that, and this component appears on your list, and now it's the time for placing it like this here. So now you can make the connections. Okay, you can get rid of this text the same way with a white space, and now you can connect the gate the same way as before to the D0 NOT, which is that one here. So in this way you go and construct your circuit. So you can move this down here, and finally you can make the next connection. And let's find now, I guess that is the 74LS20, because it's going to be a NAND of 4 inputs. So let's get it, 74LS20, right? Like that. So click, and now it is on the list. You can change the gate on the list, but now let's take it, 74LS20. Let's place it here in the circuit, and perhaps it's time for getting, for example, the 1, you know, the high level. So this is something that you can get here from terminals. Yes, terminals, you know, ground is a 0 and power is considered to be a 1. So you can make that connection here. So this is a 1 forever. And now the other 3, and I see that this input goes connected to D1 NOT. Okay, the next goes to the A, and the last goes to the B, like that. So very well, this is perhaps the last connection, the one from this gate to the final AND. And here you are, the 2 factors. Okay, this factor and the other one, the 2 inputs to the last AND gate. So this is your circuit, D1, D0, A and B, with, you see, this is an input connector that connects to the parent sheet of paper, you know, an input connector, and this is an output connector. If you delete it accidentally or whatever, you know, the connectors between the sheets are here. You see, this is a connector, terminal connectors, you see. So this is an input and this is an output. So you can get it again. You can place it on your circuit, and with a wire, now you can name it to be the one which is already in the list, or you can name it with a keyboard, like that. So now let's let it be the circuit finished. Now you can go to the parent And now it's time for simulating. You see, you have a question mark because now the circuit is captured. So now it's a good time to save it. Save the project as it is. So the project has to appear in your right folder, which is your LCSD, P1 and Proteus. You see, you have a backup copy and you have your circuit. So very well. So this is what you are going to simulate now, right? So you can click here and play, and now you see you can start from the very beginning. 0, 0, 0, 0 is the first position of the truth table, and here is what you've got, a 1. So 0, 0, 0 is a min term of the table. Then you can go 0, 0, 0, 1, and this is again another min term. You can go now 0, 0, 1, 0, and this is a 0, and then 0, 0, 1, 1, and this is another max term. So have you see that how it works? The circuit is running as if it were in the lab. You are applying logic values at the inputs and you are getting the outputs from the circuit. So you can go to the end. Now you have a 4, which is a min term. You have a 5, right? You have a 6, which is another min term. And finally you have a 7, which is a max term. And in this way you can go to the end. So finally you have the full table. All right. So when you finish with all the combinations, you save the project, and that's all. Okay, so you are solving the circuit in the simulator like this, applying different combinations, and at the same time in a sheet of paper you are annotating every single combination results. So you see, you find min terms, which can be expressed like this, or max terms. So now, for example, you can go to the end. For example, if you have 1, 0, 0, 0, this is what you have to do here is 1, 0, 0, 0, so you get a min term. So you go back to the sheet of paper and you annotate it. 0, 1, 0, 1, 0, 1 is the 9, 1, 0, 1, 0 is the 10, and then 1, 0, 1, 1 is the 11. Okay, so the 9 is going to be like this, 1, 0, 0, 1, another min term for the 9. And now the 10 is 1, 0, 1, 0, like this. So now you can try that for real. 1, 0, 1, 0, and you get a new max term. And so on. The next one is a 1, and then I guess that the other 4, 0, 0, this is the 12. You see, the 12 is a min term, the 13 is a min term, the 15 and the 14 are min terms. So you can finish now the table in your way, filling in the remaining terms. 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 0, 1, 1, 0. And 1, 1, 1, 1. So these terms are all min terms in the truth table. So this is the end of the circuit. And now it's time for comparing results. Okay, now it's the time for comparing results. And if you have to do that, you can use the max terms and min terms expressions very well, because you know here you know that this is the 0, the 1, the 2, the 3, the 4, the 5, the 6, the 7, okay, the 8, 9, 10, 11, 12, 13, 14, and 15. So now you know that the W is a function of the D1, D0, A and B inputs, and this can be expressed like this in this truth table way or format, or as a product of the max terms, that one which is the 10, the 2, the 3, and the 7. That's another way to express the table. And logically there is the other canonical form, which is the sum of min terms, and those are the terms that are not max terms, so it is very easy to pick them all except the 10, the 2, the 3, and the 7. So you're going to be the 0, the 1, the 4, the 5, the 6, the 8, the 9, not the 10 but the 11, the 12, the 13, the 14, and the 15. So this is the same equation using min terms. Alright, so now it's time for finding your colleagues or your teammates and comparing results. This is what you get from the circuit W. And naturally, now is also the time to solve the same problem. For example, using if this was the method 1, alright, now you can solve the same problem using the method 2, which is based on equations and Wolfram alpha, or the method 3, which is based on an analysis, a handmade analysis using Boole's algebra, or even the method 4, which is going to be translating the circuit's equations into VHDL and trying to use the electronic design automation tools like Quartus Prime and Model Sim to get something like this, the truth table of the circuit, which naturally has to be the same. All right. Okay, so if you've been comparing this expression and it is right, not before the circuit is finished correctly, but if the circuit is okay, now it's time for reporting, right? And reporting means, generating some kind of written document like this one to show that you've been through the process of, developing the circuit, running the simulation, and saving results. So one way to do that very easy, because here what is important is to capture the circuit. This is a kind of, development section, you can go and write development, which, it's the section 3. So development means, you see, development means going to the circuit, for example, and taking a picture. This is the picture that demonstrates this one and the other down there. Those are the pictures that demonstrate that you've been capturing the circuit, right? So that is what you can do now. You can just take a picture, all right? You take a picture of these. You see the circuit is not simulating, but this is you copy the picture in the report sheet of paper, and this is, this one along with the internal architecture. So you go to the child sheet and you take another picture of the circuit that you've been capturing from the one that was similar. Remember, you copy, and now it's time for pasting the circuit. So this is a kind of the demonstration, you see that you've been capturing this. So now it's time for make annotations, whatever. Capturing the circuit. You see, handmade annotations. This is what is important. This is my design. All right, my circuit, my design, and you can, this is, whatever that makes it your circuit. So this is the 74 LS-00 2 input NAND from the 74 LS library. It's a good way to go reporting what you do, right? And now what goes next, getting, you may say so, you obtaining, you can continue here, obtaining the truth table. So very well, this is what you do now, obtaining the truth table. And to do that, you can simply go to the circuit simulator and run the simulator. You run the simulator, and now you get some values. For example, click, the circuit is running. For example, this is okay. You see the 8 and the 10. So now it's okay. So this is, you see, if you've got values here, this means that the circuit is working fine. So you print the screen another time and you select the window of your interest, you copy again and you paste it here, and not 16 times, but 1 time or 2 is okay. But you know, after having pasted the picture, it's your turn to make annotations. For example, I'm trying here the combination 1010, which is generating the max term 10, you see. So okay, and so on for 16 combinations. So here you are, the truth table and the final exercise. Okay, and now is your turn to go and to save that. So you have to save the file, for example, solution docs, save the file as, you know, in the good and right place. And this has to be in P1 Proteus, and here is where you are going to save the file. A file that later can be scanned or can be whatever, you know, uploaded as you report of the exercise. Just the way you are submitting your solution for correction purposes and getting grades. Okay.